sir.
Yeah,
Good morning,
Good
sir.
thank you.
morning, sir.
Thank you. Thank you. So, what we were studying in last class? Come on,
Membrane technologies.
membrane technology. Okay, so in that, what we studied? Hope this PPT is visible.
Yes, sir, visible.
Okay, so we studied how to do the desalination of water by reverse osmosis method. Okay, so to know the reverse osmosis, first you should know what is osmosis. This osmosis is nothing but the movement of solvent molecules from low concentration side to high concentration side through semi-permeable membrane. Okay, only movement of solvent molecules, right? And during this process, some pressure will be exerted on this semi-permeable membrane that is called as osmotic pressure. And if you apply pressure more than this osmotic pressure on the higher concentration side, then the movement of water molecules will be reversed. That is, it starts moving from higher concentration side to lower concentration side. Okay, so that is called as reverse osmosis. You are reversing the natural osmosis process by applying the pressure on higher concentration side, right? So this is called as reverse osmosis. So this diagram I shown other day. Okay, so here these red dots are water molecules, and blue dots are dissolved salts or any impurities. Okay, so during the normal osmosis process, okay, what happens? There will be a movement of only this water molecules, movement of only water molecules through the semi-permeable membrane. Okay, so these red dots are moving through the semi-permeable membrane. So this process is called as osmosis, and during this osmosis, there will be some pressure exerted on this membrane, semi-permeable membrane. And if you apply pressure on this side, how much pressure you have to apply? It should be more than this osmotic pressure. Okay, so if you apply that, what happens? The water molecules will start moving in opposite direction, that is reverse direction. Okay, and you have natural osmosis process. This technique is used in our water purification. Right. So this is the reverse osmosis I explained, and these diagrams will depict the process of osmosis, osmotic pressure, and reverse osmosis. So here there is a natural osmosis process, right? So we have not applied any pressure here, and here in this process, in this diagram, we applied the pressure which is greater than osmotic pressure. Then the water molecules started moving from higher concentration side to lower concentration side, and this process is called as reverse osmosis. You can see this animation here. This is reverse osmosis, that is movement of water molecules from higher concentration side to lower concentration side through this semi-permeable membrane. So this is called as reverse osmosis. You can see here, this is osmosis process. This is the semi-permeable membrane, and water molecule is moving from lower concentration side to higher concentration side. Okay, these are salt molecules. It is shown here. See, this is the natural osmotic process, spontaneous osmosis process. And this is the semi-permeable membrane, which is used in osmosis process. Now what we are doing, we are applying the pressure here, pressure on this side, reverse osmosis. During reverse osmosis, we are applying the pressure. The water molecules, only water molecules, not other salts and other impurities, will not pass through this semi-permeable membrane. So here you are getting pure water. So this is one more setup wherein we used this semi-permeable membrane or RO membrane, reverse osmosis membrane, and we are applying the pressure, and other side you are going to get pure water. And this is one more technique, right? This is a U-shaped vessel. So here in between, in the middle, we have used a semi-permeable membrane, and pure water and brackish water or concentrated water is separated by this semi-permeable membrane, and we are applying the pressure on this concentrated water, right? And we are inducing the reverse osmosis. Only solvent, that is water molecules, will pass through this semi-permeable membrane, and the pure water is collected here. And this is one schematic diagram, where is this ocean water or brackish water. It is first subjected for pre-treatment, and then it is subjected to reverse osmosis. And also, if you want to remove any pathogenic microbes, you have to, after this reverse osmosis, it should be subjected for UV irradiation. And we studied what are the membranes used in uh, reverse osmosis process. Okay, the commonly used membrane used in reverse osmosis process is polysulfone membrane. Okay, so what are the advantages of using this polysulfone membrane? Also, we studied other class, right? So by looking into this polysulfone membrane, can anybody tell me what are the requirements of a polymeric membrane which is to be used in osmosis process or reverse osmosis process? What are the requirements?
When
Come
they
on.
form polymers, they're supposed to leave some gap for the water molecules to pass.
Pardon? Can you repeat it?
When they make a polymeric structure, they're supposed to be like have holes which let the water pass through, but not the salt.
Okay. So this is RO membrane, right? The
Hmm.
pore should be very small. It should
Yes,
allow only the passage of water molecules, not other
salt.
impurities like salts and other suspended impurities. Okay. What else?
Sir, it should have hydrophobic and hydrophilic nature.
Yeah, balanced hydrophobic and hydrophilic nature. It should be balanced, right? It should not have more hydrophilic. It should not have more hydrophobic. Very good. Okay. These two properties should be balanced. Okay. Then what else? There should be some clogging of the pores, right? Because of the deposition of these impurities on the membrane surface, right? So that is called as what? Falling of the membrane. This falling of the membrane should be minimized by placing some functional groups which can act as a brushes. Okay, so that should be there. Some functional groups should act as a brushes. What are the functional groups which are acting as brushes here in this polysulfone
Two
membrane?
methyl groups,
Methyl,
sir.
methyl.
Yeah, two methyl. These are called as gem dimethyl groups. Okay, so they will be rotating. By this rotation, they can give some brushing action on the polymeric surface. Okay, all these things we studied in other class. This is the animation wherein you can remove this uh, deposited salts or and other insoluble impurities. Okay, so this is caused by this gem dimethyl groups, because it is always rotating about carbon atom. Okay, and this is the some cross-sectional and transverse sectional pictures, microscopic pictures of polysulfone membrane. Okay, so you can see holes here. So this will consider detail in after some time. Okay. Now we studied the advantages and disadvantages of desalination of water also. I'm not going to going in detail about this. Now we'll pass on to the preparation of membrane. Now you will be knowing what are the requirements of the membrane which are used in uh, reverse osmosis process or any membrane technology. Okay. Now, how to prepare these membranes then, polymeric membranes? So here we are not studying any synthesis of the polymer. Already synthesized polymer you have to take, but you have to convert it into membrane. Okay. So bulk polymer will be there. That polymer will be converted in the form of membranes. Okay. So there are several methods for the preparation of membranes. So first method is non-solvent, typically water. Non-solvent induced method, that is non-solvent induced method. This is also called as NIPS method, NIPS method. Okay, non-solvent induced method, polymer synthesis. It is called as NIPS method. And then, so here we are. What is the difference here is we are using one water as a solvent. Okay, not for dissolving this polymer, and to remove the organic solvent we are using that one. So what we are doing here is we are dissolving this polymer, okay, in one polar organic solvent, and the polar organic solvent should be miscible with the water. That kind of polar organic solvent you have to take. Okay, we'll consider this in detail later. We'll see what are the different methods available for the preparation of this polymeric membrane. This first method is NIPS method, and second method is solvent evaporation. So solvent induced method. Okay, so that means you just have to take you just have to dissolve this polymer in one volatile solvent. Okay, you spread it in the form of water. You spread in the form of a membrane. Okay, on substrate. Then you just evaporate the solvent. So if you peel up the polymeric substance, it will come in the form of this membrane. So that is second method. And in third method, precipitation by absorption of non-solvent, that is water from the mixture. Okay, so this is third method, and here you are not going to get good quality of membrane. And vapor induced method. Okay, this is also called as VIPS method. So you have to convert this polymer into vapor phase, and you have to condense somewhere, and then you are going to get the membrane. Okay, so this is called as VIPS method. And precipitation method. This is called as TIPS method. Then, but we are not going to study all these methods in your according to your syllabus. We will consider only this first one, NIPS method only. So because of the time constraint, we are considering only this one. Right. So this membrane technology itself is one course if you want to study that. Right. So that is why just for the time constraint, just because of time constraint, we are taking only the first method. Now we'll consider the polymers which are what are the polymers used in this membrane technology, right? So to prepare the polymeric membrane by this NIPS method, you should identify the polymers, right? The polymers which are commonly used are, as you studied already, that is uh, polysulfone membrane. Okay, so this is called as polysulfone membrane, and second one is polyurethane membrane. This is called as polyurethane membrane. PU membrane. So this is polyurethane membrane. These are the two polymers which are used commonly in the manufacture of your polymeric membranes, which are used in membrane technology for water purification. Okay. And you know why by looking into the structure, you can analyze why these polymers only can be used, right? First one you already know. Second one also, there are some polar groups, right? This amide group, CONH group is amide group. So because of the presence of amide group, it will be having a hydrophilic nature, and because of the presence of this aromatic ring and this CH2 group, it will be hydrophobic in nature. Okay, and also this methylene group, it is always rotating about carbon atom, rotating about this uh, axis, polymeric axis, right? So therefore, that can bring about the brushing action on the polymeric surface. So this minimizes the clogging of the polymeric surface, right? So that is why this also can be used as a membrane in membrane technology. This polymer also can be used in the manufacture of membranes, right? So this is called as polyurethane. And now we'll consider the NIPS method. Okay, so NIPS method is nothing but non-solvent induced phase separation, right? So non-solvent induced phase separation. Non-solvent here is we are using one water as the non-solvent, and other organic solvent we have to use as a solvent to dissolve the polymer, right? Now we'll consider what are the steps involved in this. The preparation of polymeric membrane in NIPS method involves the following steps. It is very simple method, and first step is you have to identify the proper polymer, suitable polymer you have to identify. Okay, so as I told, as I shown the structures, the commonly used polymers in the manufacture of polymeric membranes are polysulfone and polyurethane. Okay, polysulfone and polyurethane can be used. And these polysulfone and polyurethane membranes are dissolved in one organic solvent. Okay, so usually these polymers are highly polar in nature and they are not soluble in non-polar solvents. You know what are these? What is the difference between polar and non-polar solvents? Just for your information, just for the knowledge. You might be knowing, right? Polar solvents and non-polar solvents.
Yes, sir. Polar solvents are dissolved in water, but non-polar solvents dissolve only in organic solvents.
Okay, most of the organic polar solvents are miscible with the water. Okay, that means they will dissolve with water, dissolve in water. Okay, and these non-polar solvents. Can you give me some examples for non-polar solvents?
CS2.
Benzene,
Pardon?
sir, benzene.
Yeah, benzene is the non-polar solvent. Very good.
Actin.
All alkanes, right? So hexane, heptane, octane, nonane, all these are non-polar solvents. Okay, they are not miscible with the your water. Okay, very good. So here, what solvent we are taking is one polar solvent we are taking. You have to identify one polar solvent in which the polymer should be soluble. So these polysulfone and polyurethanes are usually soluble in highly polar solvents. Okay, so the high polar solvents used here are dimethyl formamide. It is represented by DMF and N-methyl pyrrolidone. Okay, N-methyl pyrrolidone. So this is represented by NMP. So you should remember the structures of these things just for your information. Why these are considered as polar solvents and all. So it is called as NN dimethyl formamide. You know what is formamide? Formic acid, you know?
Yes, sir.
Yes, sir.
Come on, what is formic acid?
HCOOH.
COH.
Ethanoic acid.
What is the formula of formic acid? You don't know?
HCOOH.
COH.
C double bond O OH. OH. Okay. This is called as formic acid. So formamide, how will you write? Usually what are amides? Acetamide, you know, acetic acid is converted into acetamide. Formic acid is
HCONH2.
converted CONH2. Very good. So if you write like this, this is formamide. Okay, HCONH2 is formamide. And if you want to know the dimethyl formamide. All the two hydrogen atoms of this formamide are replaced by methyl group. So hydrogen atoms are replaced by methyl group. So this is called as N-dimethyl formamide, or in general dimethyl formamide. And this is a very good organic solvent, very polar organic solvent, but it is miscible with the water. The moment you add water to this, it will mix, or it is soluble in the water. Okay. Another similar solvent which is used in this polymer membrane synthesis is pyrrolidone, N-methyl pyrrolidone. It's a cyclic compound, N-methyl pyrrolidone, double bond O. So this is one more solvent. These two solvents are usually used in the synthesis of polymeric membranes, because this polysulfone and polyurethane polymers are usually soluble in these solvents, and also these solvents are miscible with the water. Okay, so just remember N-methyl formamide and dimethylamide, N-dimethyl formamide and NMP, that is polyurethane, are used as solvents. Okay. Pouring of the polymer solution, that means first what you have to do, you have to select one polymer, suitable polymer, right? So here we are using a polysulfone and polyurethane, and you have to dissolve this polymer, selected polymer, in one organic solvent, that is polar solvent, which is miscible with the water. So usually we can use this DMF or NMP. Okay, you take any one of the solvent and dissolve it properly in the solvent. What you have to dissolve? You have to dissolve polymer. Then you pour this polymer solution. Once you dissolve it properly in the solvent, you pour this polymer solution on a clean glass plate. Okay, you take any substrate, any uniform substrate you take, or usually glass plates only used here. Okay, so pour this solution on the glass plate and make a uniform surface there. Spreading of a polymer solution uniformly on the glass plate using different techniques. There are different techniques used to make the uniform surface there. Okay. Then once you make the uniform layer there, you have to dry it in the oven. Partially you have to dry. You are not supposed to dry all the solvent, right? So partially it should be half dried in the oven, and it is optional. It depends on the what solvent you are going to take. If it is more volatile solvent, you no need to keep it in the oven. If you keep it in the air, solvents will evaporate. Okay. If it is high boiling solvent, you just have to keep it in hot air oven for some time. Okay. Then half of the solvent is removed from that layer. Then what you have to do? You have to dip this plate, glass plate, in the water which contains in the glass plate in the bowl which contains water, pure water. So that polymeric membrane along with the glass plate is dipped in water. Right? Now you can peel off that polymeric membrane. I'll show you the diagram here. Polymeric membrane, and which some pores are also formed in that polymeric membrane. I'll tell you how the pores are formed on the polymeric membrane. Okay. So what is the first step here? First step is selection of the suitable polymer, and second step is dissolve that selected polymer in an organic solvent which is miscible with the water. Usually glass surface, and make it spread it uniformly by using different techniques. Some blades are used or some gliders are used, okay, to make the uniform surface. And then you have to dry that one in hot air oven. Okay, dry that hot air oven. It depends, right? It is optional. And if once you dry that one, the whole setup is dipped in the water, right? Dipped in the deionized water or pure water. Then you can peel off the polymeric membrane, and that polymeric membrane forms the hole, small holes. I'll show you how it forms the holes and all in next slide. So is it understood? Is the steps are understood? Very simple steps, sir.
Yes, understood.
Understood, right? Okay. I'll go to next slide. Here, I'll show you how this holes are formed. You know that you have to take in first step. You are taking the polymer, selecting the polymer, and you are taking you are dissolving it in a solvent. You are going to get this uniform solution, and this uniform solution is spread on the solid support. Usually, the solid support used is this glass plate. Okay, so you are pouring this on the solid support, and by using this blade or gliders, you are making the uniform solution. Right. So uniform solution. Once you make the uniform surface here, this polymer along with the solid support is dipped in the water here. It is dipped in the water. Okay. So when you dip in the water, what happens? There will be some solid molecules trapped inside this inside this layer, right? Solid molecules will be there. They are not dried properly, right? So once you dip that one in water, what happens? Those solid molecules will come out and dissolve in the water, right? When they are coming out, they form the small holes like this. Okay, they form a small holes, right? So that this kind of membrane is used in your membrane technology. So one of you told it should have some small pores to allow the passage of water molecules, right? So these small pores are formed by this mechanism. How they are formed? Because this solvent is trapped inside this polymeric membrane. When you dissolve it in water, okay, that water molecule will also enter into the diffuse into this membrane, and that will combine with the solvent which is already there in that, and that solvent along with water, it will come out. So in this process, they will form a small pores like this. Okay, and this is the efficient method for the manufacture of your polymeric membranes, which are used in membrane technology for water purification. Okay, so this is a very simple technique, economic compared to other techniques. Okay, in vapor phase technique and all, you have to heat the polymeric membrane. Sometimes polymeric membrane may undergo decomposition. Here there is no such decomposition and all expected, because if you dissolve the polymer in non-polar solvent, it doesn't lose its properties. Only it will go into the solution. Okay, and you are removing the solvent here again by dipping in the water. Right. So any doubt you are having here? So once you peel off your polymeric membrane, that can be used as a membrane for water purification. Here the selection of solvent and required polymer is important. So solvent should be what? What are the requirement of a solvent to be used in this NIPS method? Come on.
It should be polars.
It should be polar. Of course, it should be polar. Then
Able to dissolve in water.
yeah, it should be miscible with water. Very good. So then only you can use that solvent for dissolving the polymer. Right. Very simple method. Select suitable polymer, dissolve it in one organic solvent which is miscible with the water, and spread it on the solid surface. Make it uniform surface by using some gliders or blade. There are many techniques to make a uniform surface. So dry it partially, then you dissolve or dip it in the water, right? So if you dip it in the water, what happens? That polymeric membrane will be peeled off from the glass surface, okay, and also the solvent molecules which are trapped inside this polymeric membrane, right? So they will mix with water and they will come out. So during this process they will form the pores. right? And this membrane can be used as the polymeric membrane in water technology or desalination of water. Okay, have you understood this? Are you able to write if it is asked in the exam?
Yes, sir.
Sure.
Yes.
Okay. Okay, I'll show you pictures of some polymeric films. These are the microscopic pictures, right? So this is a polysulfone film we have taken, right? So if you take the microscopic picture of this polysulfone membrane, so you can see some small pores like this. These are very small pores. So this will be some nano-sized pores. And if you take the cross-sectional picture, you are going to get this kind of pores. Okay, if it is cut cross-section, right? So you are going to get this small pores like this. They can be seen like this. So this allows, these pores can allow only the passage of water molecule, not other dissolved salts and impurities. And these are the polysulfone fibers. So these fibers are also can be used in the water purification in the manufacture of this thing. But we are not going to study how these fibers can be used as uh, membranes in water purification, but we are going to study only the manufacture of these membranes. And these fibers can be woven in the form of membranes like cloth. Okay. Drawing these fibers and all, it is a very important technique. Okay, after knowing this membrane technology, right? So membrane technology, we are going to study this water management and sewage treatment, right? So I'm showing you, you are saying one picture here, right? So take 1 minute, you just analyze this picture and tell me. I'll give you 1 minute time. Are you able to do? Just analyze this picture. Come on, any one of you unmute and speak.
Sir, sewage water of the society will go to that water treatment facility, and through membrane technology, it will purify it and let in water body.
Okay, good. So what else?
So, but some of the wastewater is getting overflowed and enters the river.
Okay, good. What else? I want different answers from all.
The treated water also enters the river only.
What is that?
The treated water also enters the river back.
Yeah, treated water also entering the river. Okay. So is it desired or what? You have to treat water and then discharge to river, or you have to discharge as such?
You should treat it.
You should, before discharging into the water bodies, you should treat that one, right? Okay. So what all types of water you are discharging to the water bodies here that you analyze? See the pictures here. Okay. So this sewer means sewage only. Okay. Sewer means sewage only. And this sewage is domestic sewage. Okay. This gray colored draining is there. No, that is domestic sewage. And this particular sewage is from industries. Okay. So how will you define sewage then? It's a liquid waste. Okay. So it is a liquid waste discharged from household activities or industry. Are you following this or not? So the liquid waste which is discharged from household activities or industries, it is called as sewage, right? So I have shown here. This is the sewage, gray colored. This is generated from this household activities, and this is the sewage which is generated from industries. Okay, so both are mixing here. Along with this, this rainwater, okay, residential wastewater is this one, and roof area drains. This is called as roof area drain, and this is the street storm drains, okay, and this is also roof area drain. So which is more polluted here, whether this sewer or this roof area drains?
Sewer.
Sewer.
Sewer is more polluted, right? So it will be having more organic and inorganic loads, especially this sewer which is discharged from household activities, that will be having more organic load than inorganic load. And the sewage which is which is generated from this industrial activities, that will be having both organic as well as inorganic. Okay, so these are more polluted water, and we are mixing them along with the this roof area drains and this street storm drains. Can we do that? Come on, just think. Am I audible? Okay, so can you do this? Can you mix both? One is highly pure and other one is highly polluted water. So if you mix that one, what happens? The volume of the wastewater, the polluted water will be more, right? So it is very difficult to treat. So how you are going to manage this kind of situations then? So better while planning the your streets and town planning. So better to have separate drainages for this kind of roof area drains and street storm drains, and also for this kind of sewage water, right? So if you have separate this thing passage, right? This pure water doesn't require any treatment. You can discharge it directly to the water bodies, right? It doesn't require any treatment because it is not polluted. Or you can use it for some other purposes. So you just uh, 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 purify and use it for whereas this one, this sewage, right? Sewage should be treated properly before you discharge it into the river or lakes or any other water bodies, right? So this kind of process is done in sewage treatment, right? There are different stages of sewage treatment. You know that this sewage is the liquid which is coming out from the domestic and industrial sources, right? So the main origin of this sewage is domestic purpose, that is household waste as well as industrial waste. Okay, and this domestic waste is mainly containing organic waste, right? And this industrial waste, it may contain both organic and inorganic load. And this domestic waste, it is having a heavy load of BOD. BOD means biologically oxidizable impurities. And also it may contain pathogens, bacteria. It will be having this gray color, okay, and very bad odor it will be having, and very bad smell, okay. So that is the characteristic of domestic sewage. And sewage water is discharged into water bodies, leads to deficiency of dissolved oxygen and leads to the death of the fishes. or any aquatic creatures, aquatic animals, right? So you know this. So the polluted water, if you discharge directly into any water bodies, what happens? The pollution level, right? The pollution level in the water body, like river and lake, will increase. So if the pollution level increases, what happens? The dissolved oxygen level decreases. Okay, this you studied already. If the dissolved oxygen level decreases, what happens? So that leads to death of aquatic creatures like fishes and other aquatic organisms. Right. And pathogenic bacteria are causing waterborne diseases. This you know already, like cholera, your other health hazards it will cause. Okay, so cholera is the main. If you see this picture, this is the gray water, right? Gray or greenish water. It is discharge. This is the discharge of your household and industrial sewage to the water body. So one best example you might have seen in your college only, right? What is that? Have you gone through that side, other side? Rushbhavati River, have you seen?
Yes, sir.
So, staying in the hostel, they might have experienced, right? For some 1 or 2 weeks, you were there in the hostel, right? You might have experienced
Yes, sir.
its effect.
Yes. Yes, sir.
Okay. So what is that actually? Earlier it was a river in Bangalore, one holy river it was, Rushbhavati River. Okay. But now it has become what? Yeah, now it has become a drainage. So why it has become like that? Because of our egoness, our egoism. We are just discharging everything, all the household sewage into that, right? So it has become drainage now. See here, this is the pure water, pure river water, right? So to this, if we discharge this sewage water from household activities and industries, so this will be polluted. Okay. So for this, what you have to do before you discharging the sewage water into the water bodies, you have to treat it first. Okay, that means you have to remove at least some 80% of the impurities present in the water. Okay, then you can save your water bodies and then you can save your environment. Right, and the best management technique is you have to separate this sewage water from rainwater. Okay, that rainwater should be you should give some separate passage for rainwater and separate passage for this sewage water. Okay, that rainwater can be used directly for other purposes like agriculture, horticulture, and all. Okay, and then this treated water can be discharged into this water bodies, so that you can prevent the water pollution and then you can save the aquatic animals and all. The sewage treatment is done to remove contaminants from wastewater and suitable for discharging into the environment for reuse. So you can reuse that treated water also for gardening and all. Okay. Now we'll consider how to treat this sewage. That is called as sewage treatment. This is very important thing. There are different stages of the sewage treatment. First stage is primary treatment, and it is called as a mechanical treatment. Okay, and second treatment is secondary treatment. It is called as biological treatment, and third one is tertiary treatment. It is also called as chemical treatment. Right. So these are the three different steps, the three different stages for the treatment of sewage water. So what is the first one? It is primary treatment. In this primary treatment, we are going to do mechanical treatment of the sewage. That means you have to separate some bigger impurities, suspended particles. Then it is subjected to secondary treatment. In the secondary treatment, what we are doing? So we are using biologically oxidizing agents. right? So it is biological treatment. So BOD we are reducing there. Okay. And in tertiary treatment, we are using some chemical reagents to remove the impurities, right? So these are the three stages. So we'll consider these three stages step one by one now. Now we'll consider the primary treatment. As I told, this primary treatment is regarded as mechanical treatment. So in this, we are just filtering the sewage water. For example, you might have seen our Rishbhavati river. So what all bigger particles are flowing into that? Paper, plastic, wood, wooden pieces, all those are flowing, no? And also some other suspended particles will be there. So those are coloring agents and all, right? All those things should be removed in this primary treatment. Okay, so this primary treatment is used to remove suspended solids, and also odor you can remove, color you can remove, grease and oil you can remove. Some oily impurities also can be removed in this first stage only, that is primary treatment. And different stages of this primary treatment are as follows. First, it should be subjected to screening. Screening means it is the process of removal of larger floating materials like wooden pieces, glass piece, and leaves, etc. from the water. Okay. So whatever bigger suspended particles are there, so you have to filter them by passing through the screens. Okay. So this process is called as screening. Are you following this or not? Very simple
Yes,
it is.
Following, sir.
Yeah. So you have to subject it for screening. So if you subject it for screening, you can remove some floating impurities, floating materials. Okay. Then it is subjected to, then raw water is allowed to pass through screens having small openings which retain the floating and suspended coarse material. Okay. So it is again one more filtration process, right? Then it is subjected to sedimentation. So there are some other suspended impurities like clays and all, colloidal particles and all. They cannot be separated by passing them into the screen. They will pass through the screen, right? So they will be subjected for sedimentation. So sedimentation depends on what? How we are going to do the sedimentation. You know what is the sedimentation? Sedimentation is nothing but allowed to settle down. Okay. There are several techniques for the sedimentation nowadays. Okay. The process of removing suspended impurities like clay and other colloidal matter, right? It is done by sedimentation process. In the sedimentation process, water is allowed to flow from the bottom to top. That means it is carried out in sedimentation tank where raw water is allowed to pass through from the bottom of the tank and slowly rises upwards. That means it is rising upwards, and because of the gravity, these suspended particles will come down, will settle down, right? The suspended particles settled or pulled down due to the gravity. This process removes only 70%, 75% of the suspended particle. So that means what you are doing, you are passing this raw water in the sedimentation tank, wherein the raw water is allowed to pass through from bottom of the tank and slowly rises upwards. So water is rising upwards from the bottom. So in this process, what happens? Because of the gravity, the other suspended particles, they are pulled down, right? So they will sink in the bottom, right? So this process removes only 70%, 75% of the suspended particle. Still some more lighter particles will be there, right? You have to remove them. So if fine suspended particles are not settled down due to gravity, are removed by adding coagulating agents such as potassium ferrous sulfate. Okay. So what you have to do, you have to use some coagulating agents. if by sedimentation some impurities are not removed, so for them what you have to do, you have to add coagulating agents. If you add coagulating agents, what happens? These coagulating agents, they will combine with this very small, very light suspended matter, and their gravity and size also increases, right? So then you can settle them in the form of settle them in the bottom, right? Are you following this?
Yes, sir.
Yes, sir. Following.
Yes.
Okay, okay. Then oil and grease cannot be removed by sedimentation, right? It is also very light. Oil and oil and grease, it will be having density lesser than water, right? So therefore, you cannot remove it by sedimentation. So how we can remove this oil and grease? So it is carried out by skimming tank. Skimming tank means it's a big tank where the compressed air is blown through raw water, right? So you just have to collect this water after sedimentation in the sediment this tank, skimming tank, one big tank. There you have to blow the oxygen or air. Okay. So if you blow the oxygen or air, what happens? This oil is converted in the form of foam, right? Oil is converted into foam and it will float on the surface, right? And you can just skim off this foam and the water will be free from your oil and grease. Okay. So just take, you do a small experiment. You take some oil in this thing, your bowl, right? And put some water and using one straw, you just blow it. Okay. So after blowing, this oil and grease will be converted into foam. It is very easy to skim off this foam, right? Okay. So like this, you can remove this oil and grease, right? So this is called as primary treatment. So first you are removing a larger floating material by just passing into the screen. Then you are subjecting to sedimentation. The suspended impurities which are not separated by screening, those will be separated in the sedimentation tank. Okay. And oil and grease, it is not possible to remove by passing into screen or by sedimentation process. For that, you have to take this raw water in skimming tank and blow oxygen or air, right? So this oil and grease will be converted into foam, and this foam floats on the surface of the water. You can just skim off, and the water, what your resulting water will be free from oil and grease. Have you understood this process? So any chemical or biological treatment we used here, it is only mechanical treatment. Okay. Only thing is we added some potash alum and ferrous sulfate. Again, this coagulants, after coagulation, we are separating by them through mechanical separation only, right? That is by filtration or sedimentation, right? So these are the three stages of primary treatment. One is screening, other one is sedimentation, and the next one is removal of oil or grease by passing air. Okay. So this secondary treatment is called as biological treatment. Secondary treatment is nothing but biological treatment. I think it is not possible to cover this biological treatment now. So I'll just continue it in the next class.